Hi, in this video we'll talk mostly about what exactly structures are, or in Rust terms, if I define the keyword, it is struct. Now, struct is quite similar to what we have in different languages, like in Java we have classes through which we create objects. In Golang we have structures as well, and in JS we have interfaces. Now, what exactly a structure is? Say suppose if you want to define a collection of different values, mandatorily not a list, but a different data structure which could contain a collection of data structures. Let me give you an example. It becomes more clear probably after that. So say suppose if I want to define a person, and in context of the person is basically a user of a website. Okay, now what are the information do I need in that case? Let's go just in a normal manner. I might need his name or her name. I might need the email address. Actually, I might need the address, and I might need any any uniform or anything which is distinguishable by that specific person, like age. So these are the four things which I probably need for that particular person to log in into a specific website or create a ID of that particular person on that website, right? How about I collect this information and put it into a specific data structure so that I do not need to individually use these variables or these attributes across my program. And that's why I could put all of them inside a structure or a class. Structure and class are basically two different things, but just to put you in context, if you are coming from a Java background or a JVM language background, it becomes much easier to understand structures actually. What I'll do here in Rust is, if I want to define a structure, I'll use the basic keyword of struct and give this structure a name. In our case, since we are discussing about a website, let's put it as a user. Now, the website can have different users as well, like user 1, user 2, user 3, n number of users, right? And each and every users will have a specific property which will be defined based on the properties which we discussed right now, like name, age, address, and email address, right? So all these properties will have their own data types defined along with them, right? Like name cannot be an integer, or name cannot be a i32 or a u32, right? It has to be a string, because it is not a sequence, it is not a character, it is a sequence of characters, right? So what I'll do is I'll just assign this structure the string data type of like the name of this structure, or the name attribute of this structure user will be of type string. Similarly, for age we can use u32. For address we could use string again, and for email we could use string as well. Now this user is basically a parent or a basic skeleton of all the users which I want to define throughout my code. So if I want to come up with n number of users, like user 1, user 2, user 3, user 4, or user x or user n, I could use the same structure for all those users, and it will reduce the amount of code which I will have to write, or it will make it my code easier to be understandable, and I do not have to come up with name 1, name 2, name 3 or different kinds of variables across the code. I could just use this user and I could use the attributes across the code. Let me show you how exactly we can instantiate the user. So say suppose we are coming up with user 1, which is my user, and I want to shape this user, so or instantiate this user. Then what I'll do is I'll basically assign the string value into name. I'm just basically defining the name of this user. I'll take my name here. Similarly, what I could do here is I could take age, since it is u32, generally assign a number to it. If it is address, in the same format, I'll initialize a string, call it Berlin. Similarly with email, I could come up with a random email address like abc@xyz.com. Yep. Now this should be commas actually, not semicolon. Now if I want to access these attributes of the user, I do not need to be worried about what exactly I need to do or I need to handle these variables with. I do not need name 1, age 1, address 2 or address 1, email 1 kind of variables. I could just access the user. The structure is basically defining the code or the modularity of the code here actually. What I could do here is I could just write println and say we have name. I want the name to be printed actually. I could just do user1.name. Similarly, we have age, address, and email. Age, address, email, and we are good to go. I could just do a cargo run. Okay, I'm missing a semicolon here. Yep. Could do a cargo run, and you could see all the values are shown here. So this is the basic usage of structure. It basically collects all the different attributes which could be a property of a particular thing. Like if I want to define fruit, I could come up with a structure called fruit. I'll show you an example, like a structure called as fruit. I'll do struct fruit. Make sure the name of the structure starts with a capital letter. Now fruits have different properties, right? Let's say the name, which should be a string, the color of the fruit, which could also be a string, the taste, whether it is sweet or sour, should also be a string, age of the fruit if possible, like it is 3 months old, 4 months old, 2 years old, or probably whatever you want to say. It should be a U32, and what not. You could define all the properties of a fruit, and if I want to initialize, say suppose a mango, then the name will be mango, color will be yellow, taste will be sweet, age will be whatever the value you want to assign. So this is the basic of structures, how exactly structures are and why exactly they are used. Now let's get into the properties of structures. To talk about properties, what I'm going to show you is creating a new object of the user type using user1's properties itself or user1's attributes itself. Let me show you. So let's say we come up with user2 here. What we could do is we want to give him a name, like let's say we have Sahaya Bilek. I just reversed my name. Okay, and the age is 32 again. The address is again Berlin. Email is again, or let's say we change the email to xyz@abc.com. okay, I end it with a semicolon this time. What I want to do is I want to print it again, so it becomes very obvious that we are able to create the user2. I'll do a cargo run. Okay, age is missing. One second. Okay, this should be So I'll do a cargo run, and you see that user1 and user2 both are printed here, right? I'll just add a statement here like this, just to make it clear that these are divided. Okay, now if you see, age and address are quite common to what we have in user1 as well, right? So why are we writing it again and again? I'll tell you a reason. If I want to use the properties of user1 itself, what I could do here is I could just add 2 dots and add user1. Okay, and what will happen now is I'll quickly comment out this part, clear this one, and do a cargo run. You see, irrespective of not defining age and address, I'm still getting the values. Now this is bought from, or this is borrowed from user1 itself, because we have used user1 here. Okay, but there is an interesting case here. What Rust will do, it will basically pass the properties of used variables of user1 by user2, and it will make user1 as incompletely or incompletely borrowable. Actually, what do I mean by this? Let me show you. If I uncomment this part and do a clear here, do a cargo run again. Okay, spelling mistake, my bad. Do a cargo run here. See, the user1's address is basically borrowed after the move. It means user2 has already borrowed the address functionality or the address of user1, and since this is a string, you're not supposed to use it again. If you go back to the rules of ownership, we basically mentioned for growable data types there could be one owner at a time, right? Now since string is a growable owner or a growable data type, actually the owner of this particular value is only user1, and if you give it to user2 or user2 borrows it, it becomes very difficult, or it becomes totally invalid for user1 to use address again, and that's why it is not able to show it and we are not able to use it. If I do if I remove the comment actually, or if I comment it out, actually what does happen now? I'll do a cargo run again, and you could see all the values being printed again. What does that mean? What exactly has happened with user1? Is it existing, or is it pointing, or it is only the address property of user1 which is invalid right now? How about I try to print out user1 as well, the complete user. What I could do here is I could just add user1. Now in order to print the user1, I'll have to make some adjustments actually. So what I need to do here is, I'll show you what exactly happens if I try to run this. It basically says user cannot be formatted with default formatter, and that is not possible actually. So what it suggests me is to come up with a different type of print statement actually. And what is that? I'll have to add here, and then when I do, I'll have to add a hashtag display actually. So yeah, this code should be here, and now we are good to go. So basically what I'm doing is I'm running the cargo run in debug mode. I'll explain it to you in some time. Now when I did a cargo run again, okay, we probably skipped this part. Now when I do a cargo run again and we are trying to print what exactly the user is, you could see value borrowed here after partial move. So the value of user has been borrowed partially after the partial move which has happened with respect to the address attribute actually. That's why the system is not able to use the memory location of user1 and it is not able to print it. If address would not have been moved or would not have been borrowed by user2, we would have been able to totally print user1 actually. But since partially user1's property or attribute has been borrowed or it has been moved to user2, we cannot show you exactly what exactly the user1 is. So this is one of the properties of structures. When your structure is being used or the attributes of the structures are used by a similar or the same instantiation of the structure, then it becomes very difficult for the previous structure to be used actually. I'll keep it till here right now, and in our next video we'll probably discuss about tuple structures, and yeah, I'll come up with more examples to make it quite clear to you how exactly structures are used. I'll keep it short on this one. I will update the Notion doc as well. I hope to see you in the next one.